Derivatives of parametric equations. A parametric equation is a set of equations that express a set of quantities as functions of an independent variable. Now, these are different from regular functions because our x and y are going to be completely separate equations. So we're going to be given a set of parametric equations which consists of x of t equals whatever the function is, and y of t equals whatever that function may be. A parameterization is a curve that consists of the parametric equations and the interval of t values. A parametric curve is a curve defined by the set of ordered pairs x, y, resulting from the functions x of t and y of t. A parameter is the independent variable common to both parametric equations and a parameterization. The parameter that we're going to be dealing with today is t, which stands for time. And of course, derivatives tell us the slope at specific points on a curve. In order to find the first derivative of a pair of parametric equations, we need to find the derivative of the y function and divide that by the derivative of the x function, which we'll denote as green, and the y function will be denoted as blue. The problem that we're going to be looking at tells us that the position of a particle moving in the xy plane is given by the parametric equations x of t equals 6t over t plus 1 and y of t equals -8 over t squared plus 4. And this problem wants us to find the slope of the line tangent to the path of the particle at the point where time equals 2 or t equals 2. The first step to solving this problem is to figure out what the problem is asking. So we have our, we have our x of t, 6t divided by t plus 1. We have our y of t, -8 over t squared plus 4. And we have our point, t equals 2. And since the problem is asking for the slope of the line tangent to the path of the curve, we know that we're going to be taking the derivative. So we can understand this problem to mean that it wants us to find the derivative at the point t equals 2 of x of t equals 6t divided by t plus 1 and y of t equals -8 divided by t squared plus 4. The second step to this problem is to find the derivative of each parameter. This is very simple. We know that the y prime of t equals 6t divided by t squared plus 4 squared. And we know that x prime of t equals 6 divided by t plus 1 squared. Now, since we have the derivative of both of the separate equations, we need to divide dy dt by dx dt, or we could say we need to divide y prime of t right here by x prime of t right here. When we do that, we have our y function on top, as we can see, the derivative of the y function on top, and we have the derivative of the x function on the bottom. Now, we know when we divide two fractions by each other, we can just take the first fraction and multiply that by the reciprocal of the second fraction. And the next step to solving this problem is to plug in our point. So when we plug in our point and we go through all the math, we get our answer 3 over 4. To find the second derivative, we have to take the derivative of our first derivative and divide that by the derivative of the original x equation. So given that x of t equals 6t divided by t plus 1, and y of t equals -8 divided by t squared plus 4, and the derivative that we just found, this has been cleaned up a bit, 16 times t plus 1 squared divided by 6 times t squared plus 4 squared. Find the second derivative. So the first step is to gather the parts we need. So we need to take the derivative of the first derivative, and when we do that, we get this long number. And then we need to, well, we already have our dx dt. We found that when we were finding the first derivative. So now we can move on to the second step, which is just to plug into the formula. Now, all we have to do is take our dy dt, hold on. We take our dy dt, set that on top, and we take our dx dt and put that on the bottom. And we're left with this answer down here, -16 times t plus 1 times t squared plus 2t minus 4 divided by 3 times t squared plus 4 cubed. And then we multiply that by the reciprocal of the second fraction right here. And it means it's times t plus 1 squared divided by 6. And since this is a free response question, we don't have to simplify any further because it saves time just to leave it as is. And now we're going to move on to vector valued functions. Now, these functions are used a lot in physics and particle motion and projectile motion. We know that they're very similar to parametric equations in that they're separate equations. We have the separate x equation that we can see here and the separate y equation that we see here. And any motion in the x-axis, so we have our graph, we know this is the x-axis and this is the y-axis. So any motion in this x-axis is never going to affect the motion in the y-axis. So no matter how hard you throw something in the x direction, it's never going to go up or down unless there's another force acting on it. So they are completely independent of each other. So when we deal with vector valued functions, we know we're usually going to be dealing with position, velocity, acceleration, speed, magnitude. So the position vector is going to be the vector with no derivative, just the original functions. The velocity vector is going to be the first derivative of that position vector, denoted by, position vector is x of t, so that means our velocity vector is going to be x prime of t. And the acceleration vector is going to be the derivative of the velocity vector, or we can just say x double prime of t, which is just the second derivative of the position function. And speed, it's very similar to velocity, except it's going to be our absolute value of our velocity function. And magnitude is just the size of the vector, or if you were to draw the vector as a triangle, like you can see right here, the hypotenuse is also called the magnitude. So we know that vector valued functions, instead of having parentheses on an ordered pair, we're going to have these little greater than or less than signs. And that's how we know they're different from just regular parametrics or a regular ordered pair. And this formula right here, the square root of dx dt squared plus dy dt squared tells us the speed of the vector and also the length or the magnitude of the vector. The integral from a to b of the of the square root of dx dt squared plus dy dt tells us the length of the arc or the distance of the vector. And what's also interesting that we can see from this formula is that when we are given a velocity graph, the area under the velocity vector will be the distance that the particle or whatever you're determining has gone. So we're going to be looking at a free response question. An object moving along a curve in the xy plane has position x of t, y of t at time t with dx dt equals sine t cubed and dy dt equals cosine t squared. At time t equals 2, the object is at position 1, 4. So x equals 1, y equals 4. The first part of the problem wants us to find the acceleration vector for the particle at t equals 2. And I went ahead and wrote down our functions. So we have x prime of t equals sine t cubed, and y prime of t equals cosine t squared. And since this is the first derivative of the position function, we know that these two equations represent velocity. And that means the next step to get to acceleration is to just take the derivative of these two functions. And so when we take that derivative and we set it equal, and we replace t with 2, we have our vector pair, negative 1.746 and negative 12.293. The next part of the problem wants us to write the equation of the line tangent to the curve where t equals 2. So to solve this problem, we need to know point slope form, we need to know our slope, and we need to have a point to find the line on. So to find the slope, we're already given dx dt and dy dt, and like we did in our like the very first problem, all you have to do is divide dy dt by dx dt. So when we have all of our information, we have the point slope formula, y minus y1 equals mx minus x1. And we know that our m is going to equal cosine t squared over sine t cubed, because that's dx divided by, dy divided by dx. And it gave us the point 1, 4, so we can just use that in our equation. So when we plug everything in, we get y minus 4 equals cosine 4, because 2 squared is 4, divided by sine 8, because 2 cubed is 8, times x minus 1. And again, since this is a free response question, we don't have to simplify it any farther because that would just waste time. The third part of the question wants us to find the speed of the vector at t equals 2. So we need to remember that speed, it's given by the formula. We have our dx dt squared plus, if it'll write, dy dt squared. And when we plug these two values in, we get our sine of 8, because we plugged in the 2 cubed like we found here, which is just sine of 8 squared, plus cosine 4 squared. And again, we don't need to simplify any farther because the question doesn't ask for the final form, and we don't want to waste time and take that away from our other questions that may be harder. This last question is a multiple choice question, so we will need to find the simplest form of the number. And this question tells us that at time t is greater than or equal to 0, which means when time is positive, a particle moving in the xy plane has velocity vector given by v of t equals 4e to the negative t sine 1 plus the square root of t. And it asks us what the total distance the particle travels between t equals 1 and t equals 3. So we already know right off the bat that distance equals arc length, so we're going to be using that arc length formula. And since it gave us v of t, which means velocity, that means that these two functions, the x function and the y function, are already derived. So all we have to do is plug it into our formula. When we do this, remember the formula is the integral from a to b of the square root of dx dt squared plus dy dt squared. So when we plug in our values, I'm sorry, that 0 should be a 1, like that. So when we plug in our values, we have the integral from 1 to 3 of the square root of 4e to the negative t squared plus sine 1 plus the square root of t squared. And now when we plug this into the calculator, you have 1 to 3 square root, open parenthesis, 4e to the negative, x is going to represent our t here, it's just a variable, squared, plus, open parenthesis, sine 1 plus square root t, close parenthesis, squared. We get our answer, 1.8606022326, or we can just say that it is 1.861.